In 1-6, we're going to look at midpoint and distances in the coordinate plane. And of course, our learning goal for this is understanding how to find those midpoints and lengths of segments in the coordinate plane. If you look at the success criteria that we have for this, I want you to be able to correctly plot a point in the coordinate plane. You need to be able to draw figures like segments and triangles in the coordinate plane. And then we're really going to focus on using a formula to calculate the midpoint of a segment in the coordinate plane. But then flipping that around, I also want you to be able to find the endpoint of a segment if you know its midpoint, and that can be a little tricky. Then I want you to use the distance formula to find the length of a segment in the plane, and the Pythagorean theorem to find the length of a segment. And then I want you to be able to explain how the distance formula and the Pythagorean theorem are related to one another. You don't have to write down the success criteria right here in your notes, but you do need to write down the title, the learning goal, and make sure you put the date in as well. Alright, so a little refresher here. Remember that the coordinate plane is made up of two axes. There's the x-axis, which is the one that goes left to right, and then there's the y-axis, the one that goes up and down. The positive values of x are to the right, the negative values of x are to the left, the positive values of y are up, and the negative values of y are down. The coordinate plane is divided into 4 quadrants. The positive quadrant over here is quadrant number 1. The negative positive quadrant over here is quadrant number 2. The negative quadrant is number 3, and then the positive negative quadrant is 4. When we name the quadrants, we're always going in this counterclockwise direction. Okay, so this way, this way, this way, this way, to name those quadrants. Now, each point in the coordinate plane has a location, or we also call that a coordinate, and the coordinate is always giving us the x part of the coordinate first, and then the y part of the coordinate second. In other words, left, right first, up, down second. So let's just do a quick little refresher here, and let's plot a few points. Let's plot the point A, which is at the coordinate 5, 4. So I count 1, 2, 3, 4, 5 in the x direction, and positive 4 in the y direction, so that's up. 1, 2, 3, 4, boom, done. That's A. Alright, that's going to be a little bit messy, but that's A. B is negative 2 in the x direction and positive 3 in the y direction. So I'm going to go left 2 units in the x and up 3 units in the y, and that's going to give me point B. There we go. C is in positive 2 in the x direction, but negative in the y direction, negative 1. So that's over 2, positive 2 in the x, down 2 in the y, and there's C. Now D has the coordinate 0, 3. That means I don't move at all left or right. I simply move up 3 units. So from here, no left or right movement, just up 1, 2, 3, and that would be point D. And then E is at the coordinate negative 4, 0. So this tells me move negative x direction 4, and I don't move at all in the y direction. So that's 1, 2, 3, 4, and I don't move at all up or down. So this would be point E. Alright, so hopefully that was super easy and you all remembered how to plot your points, because that's just something we should know how to do at this point. But if you'd forgotten a couple of those things, that was your refresher. Okay, so the next part I want to talk to you about is the midpoint formula. So get that little chunk in your notes. Now, I do want you to write all of this stuff, and I want you to try to copy this diagram very neatly and completely, but maybe make this diagram like fill up, like don't try to do it next to this, try to do it underneath so it can fill the whole width of the page. So we talk about the midpoint. Midpoint's exactly in the middle of a segment. It cuts the segment into 2 congruent parts. So if we want the midpoint, which we're going to call point M, of segment AB, segment AB has endpoints A, which has coordinate x1, y1, That's x sub 1 and y sub 1. Notice how the 1 and the 1 here are written a little bit lower. And B has the coordinate x sub 2, y sub 2. So that just means that these are like little placeholders for the x and y coordinates that we don't know. So if they had those coordinates, the midpoint would be found by performing this calculation. So M, when we write it on the outside, just tells me that this is the coordinate for point M. We would add x sub 1 plus x sub 2 and divide by 2. And then we would add y sub 1 and y sub 2 and divide by 2. And this is going to give me the x-coordinate of the midpoint and then the y-coordinate of the midpoint. You might notice we're adding those two things together and dividing by 2. That's just like finding the average. And that's exactly what's going on here. If you look at this picture, here's point A, here's point B. The midpoint's exactly halfway in between them, right? So that means that the x-coordinate of the midpoint should be halfway between the x-coordinate of A and the x-coordinate of B. Well, halfway in between is an average. And the same thing is true of the y-coordinate. So here's the y-coordinate of A and the y-coordinate of B. The y-coordinate of M had better be halfway in between those two y-coordinates. So again, we have an average. So pause the video for a minute and, like I said, get this picture down in your notes and make it so that it, like, fills the whole width of the page, and try to be nice and neat with it. It's really going to be helpful. Alright, I can't get out of this thing. There's my x. Here we go. Alright, so now I'm just going to do a quick example here. Let's find the midpoint of segment DB if D has the coordinate 4, 0 and B has the coordinate negative 2, 4. When you're working with formulas like this, I think it's super duper duper helpful to label your points x1, y1, and x2, y2. Just write it right there like I did underneath, because that can help you make sure that you're plugging things into the right spot, the right part of your formula. Of course, the other thing that you should do is draw a picture. So here we have D is at 4, 0, B is at negative 2, 4. So if I want to find the midpoint of this, I'm going to start with the formula. The midpoint is the average of the x's and the average of the y's. So I'm just going to plug in those values for x sub 1 and x sub 2, and then the values for y sub 1 and y sub 2. So when we plug those values in, we're going to get 4 plus negative 2 over 2, and 0 plus 4 over 2. Alright, so simplifying that, 4 plus negative 2 is 2, 0 plus 4 is 4, so we have 2 over 2 and 4 over 2, and then just do the division. 2 over 2 is 1, 4 over 2 is 2. Now here's why that picture I think is so important, because now we want to look at this picture and say, alright, if I look at the point 1, 2, that's right here, does it seem reasonable that that's right in the middle of the segment? And it totally does. It looks like it's right in the middle, so I feel like that's a reasonable answer. I probably did it right. If I would have gotten something like 0, 2, well, that's not even on the segment. Clearly, I would have known I made a mistake. All right, let's talk about the distance formula. This is how we're going to find the length of a segment in the coordinate plane. So in a coordinate plane, the distance, which we usually call D, again, between the 2 points x1, y1 and x sub 2, y sub 2, is given by this formula. That's really kind of big, but make sure you get all the parts right. So it's the square root of all of this stuff. X sub 2, whoops, that's supposed to be a 1 right there. That's a little mistake. Let's fix that. That should be a 1. X sub 2 minus x sub 1, and then we're going to square it, plus y sub 2 minus y sub 1, and then we're going to square it. So make sure you subtract first before you do the squaring. So again, we'll just do a real quick example with this one. Let's say we have the points A is at 0, 3, that's my x1, y1, and B is at the point 3, negative 1, that's my x2, y2. So we can plot that in my picture. Here's A, here's B, and we want to try to figure out how long that segment is. So again, I'm going to start with the formula. And let's fix that little mistake I made because I just copied that. That should be x sub 1. And then let's plug in the values. X sub 2 was 3, and x sub 1 was 0. So I'm plugging in 3 and 0 here. Y sub 2 is negative 1. Y sub 1 is 3, so we're going to plug those values in there. So we have 3 minus 0, and then we're going to square it. And then we have negative 1 minus 3, then we're going to square that. So 3 minus 0 is 3. Negative 1 minus 3 is negative 4. Make sure you keep those in the parentheses there. This is really important because when you square these numbers, they're both going to become positive. 3 to the second power is 9. Negative 4 squared means negative 4 times negative 4. Negative times a negative is positive, so we get 16 here. Now we just do the math. The square root of 16 is 25. And then the square root of 25 is 5. So the distance between A and B, or the length of segment AB, is 5 units. And that totally seems reasonable to me, because like if you look at this from there to there, that's 4 units. So yeah, that's going to be a little bit longer because it's on the diagonal. And that's in fact 5 units. So related to the distance formula is the Pythagorean theorem. So let's just do a little vocabulary here real quick. When you have a right triangle, the two segments that are connected to the right angle are called the legs, and then the segment that is across from the 90 degree is called the hypotenuse. We'll use that vocabulary quite a bit. The Pythagorean theorem says if I square each of the legs and I add them together, that's going to equal the square of the hypotenuse. In other words, a squared plus b squared equals c squared. When you use the Pythagorean theorem, always, 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 A and B are the legs. They have to be, have to be, have to be. And C has to be the hypotenuse. If you don't set it up in that fashion, you try to set C as one of the sides, the Pythagorean theorem won't work for you. So that's the only thing you have to remember with the Pythagorean theorem. We'll apply that and the distance formula and the midpoint formula tomorrow when we get to class.